Now, of course, this particular unit is not about SQL. SQL is something you get into much more detail about in a database class. Here we're using databases just because they are an incredibly common web technology. What we're really learning right now is PHP. You'll remember, this is a server-side language that allows us to communicate with You'll remember this is a server-side language that allows us to compute things on the server where we have full control. Usually the database also exists on the server. Of course, it could be a separate server, but it is something that we usually have control over as well. And so the database will be accessed from PHP. Now in our case, we're going to use a particular database server called MySQL. As I mentioned before, this is the M in the LAMP stack. Though some people also allow another database here called MariaDB, that's perfectly acceptable. There's also a LAP stack where instead of MySQL we have Postgres, which is another type of SQL database. They all work more or less the same, but require slightly different things once you finally start accessing them from your code. From here on out, the things we talk about will only apply to MySQL being accessed from PHP, but that is by far the most common situation. So MySQL itself is a free and open source database, as are most all the technologies we talk about in this class. It is relational and it supports SQL as most relational databases do. It is very popular and is taught here because it is historically the most popular database. It's robust, it's trusted, and it's maintained by the company Oracle. Oracle is a very large, well-funded company. In fact, they have a commercial product called the Oracle Database, which was originally their flagship product and still is. It costs a lot of money. It's a lot more efficient than MySQL, but they maintain MySQL as well now, which was a product they inherited and that they continue to contribute to as part of a sort of good way to contribute to the community. Our particular class server, as you've seen, it will give you access to several examples, so you will need to be able to access it, and it will be important for completing your homework. So make sure that you're able to use it. It will come up on a couple different occasions, and you'll want to be able to get to it easily. It is running a MySQL server, and that's the only part of it we're going to use. So, what does it look like to actually access MySQL from PHP? Well, of course, SQL will be a part of it, but it's the glue in between, the particular functions you have to call and the things that you have to do to establish the connection that get a little bit tedious. This is not going to be simple, but it's going to be as simple as it can be. So take good notes here, pay good attention to all the little steps that are involved in all of this. Ultimately, there are several choices. PHP's been around for a while, and so has MySQL, and over time, the way you did it evolved. There are in fact 3 completely different APIs, or application programming interfaces. Remember, an API is just a collection of functions and objects that are used to achieve a task. There's 3 of them that are all devoted to the exact same task, accessing MySQL. The first one is just called MySQL, sometimes called the original one. This is never used anymore because it is insecure. It is vulnerable to a very particular type of attack that we'll see in just a moment. The second one is called MySQL Improved, or just MySQLi, and it has 2 different ways to use it. You can use it purely by calling functions, or you can use it with objects. I'm going to use it as objects when we see it, but you'll find other places either show both ways or pick the functional one. Lastly, there's something called the PDO for MySQL. PDO stands for the PHP Data Object Interface. PDO was something that was created in PHP so that you wouldn't have to learn an entirely different way of accessing a database if you changed from, say, MySQL to Postgres. All of the different types of databases out there have a PDO driver for them. And this provides the same basic commands that you can use no matter which type of database you're accessing. It's only designed to work with relational or SQL-based databases, and there are ones that are not. And it tends to be a little more complicated than just the simple MySQLi interface, because it has to deal with quirks from all the different possible databases that might use it. Now, which one of these are we going to use? Well, we're definitely not going to do the original one. You might run into it from time to time for really old websites. We have to pick between MySQL Improved and PDO MySQL. Now, ultimately, why do we ignore the original one? Why exactly is it, I say here, deprecated? Deprecated means it's a standard that's still in there, but that you're going to get warned continuously not to use anymore. Why is it deprecated? This has to do with a particular vulnerability in SQL called SQL injection. SQL injection is basically when you cause a database to run a malicious query of some sort. That's usually what that query is going to do is destroy data. And I think this is illustrated very eloquently by a particular XKCD comic. You can look it up at bobbytables.com. I have just a couple of panels from it here. Here, a mother's talking to the principal of the school, and he says to her, "Did you really name your son Robert? Colon parenthesis, or excuse me, apostrophe parentheses, colon, drop table students, colon, dash dash." Oh yes, little Bobby Tables, we call him. Well, we've lost this year's student records. I hope you're happy. And I hope you've learned to sanitize your database inputs. What we're illustrating here is a SQL injection attack and the solution for it, input sanitization. So, what's happened here is that some sort of value you're trying to use inside of a query, in this case, her son's name, Robert, drop table students, you've inserted those into a larger query. Very often that data comes from an HTML form, and so that is where potentially dangerous things could happen. You've got just the value and you're inserting it into a pre-made query. Let's look a little bit closer at how this could happen. So here's, let's say, is the original query, the actual query that was designed. Insert into students, fname, the values Robert. So this is an insert statement. We actually haven't seen those before, but you should have read about them. It says, in the table students, the value fname should be inserted. And here's the actual value for it. Robert will be inserted as fname. So this becomes a new row in the table with the value Robert, and anything else that was in that row will just receive its default value. What happens when we insert her son's name? Well, the query becomes quote-unquote hijacked. It gets split into two statements instead of just one. So insert into students fname values Robert. That looks the same, right? And then all of a sudden there's this extra bit, drop students. This is an SQL statement that says delete the entire table students. Not a good thing. Now, there's many reasons that this actually probably wouldn't drop. Students probably has references to other tables, and SQL will say, no, I can't drop that, otherwise all these references would be broken, so other things might happen. And then lastly here, we see this little dash dash, and that turns the rest of the statement into a comment. Now, how did this happen? How did one statement become two? Well, you can see here, what was previously just Robert is now this big, long statement between the quotes. That's where drop table students comes in. Oh, I left out the table, but yeah, it should be drop table students. And so they basically changed our query on us because they guessed at what the structure of it could be. And SQL is very guessable. It's a very standard language. And so that's why this is able to happen. Now, how do you prevent it? SQL injection. Well, you never use your data without cleaning it up first. We already said that server-side validation of information is very important, and this is one of the examples where it is in fact critical. You need to sanitize your input, as the mother puts it in this particular example. So what do? When you sanitize something, you're removing things that might cause it to suddenly become a actual valid SQL statement that is malicious. So you would remove dangerous characters like single and double quotes. You simply should not accept those into your data. Or if they have to be part of your data, you need to do what's called escaping them so that they aren't part of the statement, but rather are part of the value. Similarly, you would remove SQL verbs like drop or update. And if those do have to be part of your data, again, you'd be extra careful about exactly how they go in there. Lastly, as always, you need to validate your data before you try and use it and put it in there. And if you recognize something that's potentially malicious, you should just put on the brakes and say, no, I'm not going to do it. This all requires very careful consideration and very careful programming. Good news is we don't have to do it. Most libraries will do this for you, including MySQL Improved and the PDO MySQL. And so all we have to do is make sure we're using one of those. So if we come back to our particular languages, you'll see MySQL Original does not do this. This is why it's deprecated, among several other reasons, but that's one of the key reasons. So we need to use either MySQL Improved or PDO MySQL. While learning PDO might be useful because it would be able to be applied to other databases, I find it's considerably more complex than MySQLi. So I'm going to stick with MySQLi. It's still not a simple language or simple interface to learn, and so you can imagine PDO tends to be even worse. So for the sake of simplicity, we're going to stick with that. So what does MySQL actually look like? Well, to sort of learn it, we're just going to go through the process that you would use to create a basic select query. Again, select is all we're going to focus on in this class. And you can imagine there's a similar process for other kinds of queries as well, but the select query is what we're going to tailor this to. And there are 5 steps. We need to first connect to the database, and there will be a command for that. We need to then prepare the query, and there will be a couple commands for that. We then run the query. We bind the results to variables so that as the data comes back to us from the SQL database, we'll be able to access it from variables. And then finally, we fetch the results. And this is what actually stores them into those variables so we can read them out. I like to think of this as CPRBF. CPR for your best friend, which is just one of those dumb things that professors come up with to try and help you remember something that's a little bit complex. This is my own thing. You won't find other people that have put this together, so if you don't like it, just ignore it. It's not going to hurt you anywhere else, but I'm just trying to give you a sort of mnemonic device. CPR for your best friend, CPRBF. Connect, prepare, run, bind, fetch. We have to do all of these things. Some of them will be able to be simpler if your query is really simple, but I'm going to show you the most generic case initially here. Let's go through each of these steps and see what they look like. We'll come back and actually put this into practice here in just a moment as well. So, step 1, connect to the database. To do this, all you actually have to do is create the mysqli object. Now, if you were doing the functional approach, you would actually need to call the function that's appropriate. But for our purposes, we're doing the object-oriented approach. And so we just create that basic mysqli object. And then check for errors. Here's what that looks like. We say new mysqli, like we're creating an object, and then here's the things it needs. It needs to know the name of the host, the actual server. Sometimes this can be localhost if it's the same as the one that your web page is running on. It won't be for us. It then needs a username and a password. MySQL uses user accounts to control who can access what and what they're allowed to do. So you will have to supply a separate username and password just for the database. And lastly, it wants to know the database of the name of the database you want to work with. We pass in those 4 things. It will attempt to connect. If there is an error, it sets 2 things. It sets connect error no, which is error number, and connect error, which is a description of the error. So we check that. If database connect error no is actually set and greater than 0, that's what this basically means, then let's print it. We would print out what the error was. We would also probably at that point want to quit. So very often you'll see this as die error connecting db connect error, and that's it. Where die means here's your final words and stop running. I usually opt to not do that, but in fact to try and keep going if I can. So this is step 1, these 2 lines of code, or less 4, but really only 2 of them are significant. Once you're connected, we have this new object to work with, $db. That's just a variable. I've stored the results of the connection into that, and we're going to use that throughout. You see us using it here and here. It is the actual database connection, and so it's going to be important in later steps here. Step 2, we need to prepare the query, and first we're going to see the unsafe way to do it. First, we call the function prepare, and this is going to return a statement object, and then we check that the statement is valid, and that would look like this. So here's our query first. I'm getting that all set up, and I'm just storing it inside of a variable, query. So this is just a string. It's a big long string that involves putting a variable in the middle of it. You notice I kind of had to do that separately because I wanted to put it in quotes as well, so it's a little bit complicated. The string contains a semicolon, but there's also a semicolon at the end of the PHP statement. Again, this is polyglot hell. We've got multiple languages inside of one another. SQL inside of PHP. So we'll have to get a little used to it. Once we have the query set, we call db prepare, and prepare takes that query and gets it ready to go. And it will return back a statement object. I usually just abbreviate that STMT. So we prepare, and the statement object that's returned goes into this variable. The first thing you want to do is check that it's valid. So if we just say if not statement, that means we didn't get it back, and we need to say what went wrong. So we say error preparing, and we look at DB error for that, because the error will be on the database object. If it failed to create it, statement won't be anything. The error will be on DB. So we say DB error. We try and print that out to give more information. Now, as I mentioned, this is the unsafe way to do it. In fact, you can probably see right now, this is vulnerable to SQL injection. Now, all we're doing is select right here, but they could hijack it and turn it into a drop statement or a delete statement if they wanted to. And that is because we're directly using a variable right inside of our query. We're taking whatever value is in $name, which could have been set earlier, and putting it right in the query. We didn't check name to make sure that it doesn't contain malicious code. So let's look at the right way to do this. It's going to make step 2 a little more complicated, but it's important. So the right way to do it will require us to prepare the query with sanitizing. The first 2 steps are still the same. We call prepare to create the statement object, and we check that the statement is valid. But then there's another step. We're going to call bind param, and that will sanitize the value before it gets put into the statement. So here's what that's going to look like now. Our query now, instead of containing the actual variable here, just says name equals question mark, where question mark is going to be the actual value coming into the database. This becomes a placeholder. It's sort of a blank. And when we pass this into prepare, prepare will recognize that question mark, and it will be ready to receive a value for it. Now, the prepare statement and checking if the statement was successful are still exactly the same. At this point, we now have a statement object, and we will go ahead and call bind param. We need to call this to make sure all of our blanks, and there might be more than one, get filled in with a value. In this case, there's only one. We need to tell it what type it is, S is for string, and then we need to give it the value. If there were multiple ones, we'd list a single character for each one, SSS if there were 3 and they were all strings, and then you provide 3 values, maybe name, comma, gender, comma, last name. You could provide them all right here if you need to, and we'll see examples of that later on. Right now we're keeping it simple with just one. It will then sanitize the variable. It will look through and make sure it's okay and escape any potentially malicious characters so that they don't wind up actually becoming part of the query. It would then, that particular function returns either true or false. So if we get false from it, not that statement, something went wrong and we need to let them know what. This time the error message is on statement, not on DB, because statement was what we called to run the function. So this is the most complex step by far, step 2. Make sure you're comfortable with it, and you'll get some practice with it, of course, in working on the actual homework for this particular section. Let's move on. So you can see here where we set the parameter with a question mark up here, that actually gets given a value when we call bind param dot here. So for every question mark down here, there needs to be a type in the bind param and then a variable to fill in its value. Or it could just be a direct value, but almost always it's a variable. Now, step 3, we need to run the query. This one's pretty straightforward. You basically call the function execute on the statement and then check for errors. Once again, we're always checking to make sure it succeeded. This looks like this. You take the statement, call execute. If it returned false, so if not statement execute, then we say what went wrong. And again, statement error is going to contain more information about the last error that occurred for the most recently called function. Now we need to bind the results to variables. So at this point, the query is okay. It was accepted. It basically ran on the database. And the database is ready to give us the data, but it hasn't actually given it to us yet. It does that in stages. The first thing that we need to do to prepare to receive that data is give it some variables to put the data in. We're going to do that in 2 steps. First, we're going to store the results, and that actually brings them over to our local memory space in PHP. And then we're going to bind those results. Finally, we check for errors. So here's what that looks like. You can just call statement store result. This takes those results and stores them locally so that the rest of statement is actually filled in and accurate. This allows us to then check num rows. Statement num rows is how many rows were returned by the query. So if you try to check this before you call store results, its value will be inaccurate. So that's why we call store result first. Then we would want to examine, were there some rows returned? If not, we want to say error, no rows returned. Now maybe that's actually what was intended. Maybe they wrote a query to make sure that there were no rows that fit it. So it's not necessarily an error, but most of the time it is. So it's something that you usually want to flag the user about, and you wouldn't want to continue on if no rows were returned. Now here, we then need to tell it how we're going to receive the information. Now remember, we asked for two things, a name and a password. Let's go back and see that here. Go back to the original query so we can see what it looked like. Here it is. We basically said select name, comma, password from student. Oh, it should say from student. Sorry, that's an error in the query here. So select name, comma, password from student where name equals something. So we told it to select two things, name and password. The next thing we need to do when we're actually receiving the results back after we've stored them and checked the number of columns is we need to bind those two things. So for everything you listed, you need a variable to receive it. Username and password are the obvious ones here, and so we're going to use those. So we bind to username and password. Again, we check to make sure that ran correctly, so we say if not statement bind result, and in that case we would output an error. Now we are ready to actually fetch the results. This is the last piece of the pie. All this really does is take the data that was returned and put it into those variables that we've bound to the information. So you usually run a test or you loop over the fetch statement. You'll see what I mean by that in a moment. And then you get the data from those bound variables. So here's what that might look like. We run the function statement.fetch. Fetch will return true if data was actually returned. So you put it inside an if statement. If statement.fetch was true, then that means username and password are ready and you can actually output them like we do here. Now, I say you would either test or you would loop because it's possible there would be more than one, of course. So you might like to keep fetching. And if that's the case, you usually just use a while loop. While statement fetch is true, and will keep returning things, you can keep outputting the name password pairs. So that would allow you to get all of that information out to the console. So you, depending on whether you're going to have just one result expected or many results expected, you either say if or you say while. Very little difference otherwise. And at that point, you're all done. So the full steps here again, 1, 2, 3, 4, 5, are CPRBF. Let's go through these and actually try to do them in a PHP page. And so we'll put this into practice.